I hope everybody can see my screen. And so it's the first short introduction in digitalization in battery manufacturing. What is our, let's say, workshop theme? As you know, my name is Arno Quade. I'm coming from Braunschweig, or Brunswick in English, and we are operating there the battery lab factory. It's about 150 PhDs and scientific workers are in the battery lab factory. We are together with several university and Fraunhofer institutes. So why is not going to the next page now? So this is the battery lab factory, and there we are looking on the whole process chain and circular production of batteries. And so we have a focus on production technology, but also on modeling and simulation. And then for the whole process chain. And this is done in a pilot scale. And our pilot line is member of the Deep Planet Network, what you just heard from Dietrich Wolf. And if you are not member up to now or not listed in our questionnaire, then please contact me. Okay, but now we are coming to the theme or the topic of today. It's digitalization. And in the Batteries Europe Working Group 4, we had a discussion on what are digitalization in battery manufacturing about. And we divided it in the real world and in the cyber world, so the digital world. And in the real world, we really need sensors and also good communication tools like 5G. On the other side, in the cyber world, we need good models that can be on different levels. I have another slide on that. For the models for the product, which results from the manufacturing, but especially for the different process steps and also for the resources. We need some data analytics for if we run the line already. So there are 3 stages. This is divided in planning the operation line, in running the operation line, and then in optimization of the line during operation or after, for new process equipment maybe, and reducing costs and so on. And you see that for modeling we need for all these 3 phases. Data analytics is we need a line, and then we can have them for doing the running or operation of the line, and for the optimization we need an information management system and digital twins. And so we have always a connection, but from the real world to the digital or cyber world by data acquisition, and then back based on the results of the digital tools, we need or can have a decision or control of the processes and so on. So the digital twin we need, so the models we need, so they can be on material scale, especially if we want to predict the product behavior and also maybe have a deeper insight into the different process steps. So that is something like models on particle level or component level. Then we need models on machine scale. So for example, dynamic behavior of machines during operation, or also something like stress distribution that is regarded here to such a mixer. So what is stresses acting on the particles during mixing. And on the larger scale, we have the process chain or the whole factory. So that is usually done by flow sheet or agent-based simulations regarding the process chain, and also the whole factory simulation, including building surfaces. So it's really a lot of levels we have to look at. And now going to the 3 phases. So planning of manufacturing lines, we already have seen that in one of the presentations today. So it's on, for example, quantification of the embodied energy in cell production. If we have a factory planning and then have a look at that, then we can, for example, calculate for different constellations the energy demand. We can also then check it later, but we can use it for prediction of the used energy, and then by that, for example, also for the CO2 footprint. Another thing is how to calculate the optimal layout of the factory regarding costs, regarding throughput, and also regarding maybe production scrap, if you know how sensitive the different production steps are regarding that. And so that means you have your line, you can put in new maybe process steps as we are doing it in our competency cluster ProCell, which is a big project in Germany. So then we can predict for different constellations for the factory layout, for example, here the costs from material costs, personnel costs to energy costs, and also can do that for the throughput. And also we can calculate which number of machines we need for each process step. So now we are coming to the operation of the production line, and for the operation, usually we can have data now. So data acquisition and censoring is a really important theme. With this data, we can go into our cyber world. We can use tools from data mining, maybe also artificial intelligence tools. So we can have a prediction and can see how well the data are, and then come to the property structure optimization. That means we can optimize or can give a prediction which parameters will give us a better product or a more efficient process. Based on that, we can have a recommendation, or maybe we have a direct control of the physical world. That means here of the production line. In the production line, we have the material, the different process steps, and always intermediate properties of the product. So these are several steps, and at the end we come to the production cell. And by measuring the data from this physical world, then we go again to the data acquisition and so on. So this is what can be done regarding digitalization running a plant. Here's one example. So we have the physical world. In this case, we have an extrusion process. We can have different screw speeds, throughputs, temperatures, and so on. And we can, for example, measure the product properties by measuring the particle size distribution. With this result, we can go in the cyber world. We can have a comparison of the actual particle size distribution with the target. And by that, we can have a model-based optimization of the process parameters and can go back then to the physical world and can adjust the process to get a better result. And last but not least, we might have the goal to have an optimization of the manufacturing line. And that means we want to have a look on the cell properties and also the costs, the energy consumption and so on of the line. So it's a little bit similar maybe, or has some relation to the first point of planning a line. But here we're also going more into the production or the product properties. This is done by coupling of different simulation methods. And in this case, we are having, let's say, lower level simulations. That means micro level, so very detailed simulations. But then from these simulations, we come up to more higher levels. That means more flow sheet modeling, and can simulate the whole production chain in this project, also in this ProCell cluster. And what is, I think, very important is that we connect these manufacturing line simulations with a simulation of the cell behavior. In this case, for example, by using a 2D model and a surrogate model to transfer the data from the manufacturing simulation to the P2D model. Some examples, so for the process chain simulation, we could have, for example, DM simulation for the calendaring process step. And then we know the structure of the electrode. We can put this data into the PD model. And by that, for example, by knowing the fluctuations in the structure, we can have a probability function of the volumetric densities for different calendaring scenarios. And now my conclusion, so digitalization from my point of view will significantly enhance battery cell production from the planning over the operation or running to the optimization of battery cell manufacturing. And this digitalization will further increase the cell performance and especially the quality, as well as also decreasing costs and environmental impact. But we need better models, advanced models, and this on different scales. We need innovative sensor technologies and also, I think, a very strong interaction between different disciplines, so between chemists, engineers, and people from computer science. And that is my short presentation, maybe some hint for our conference, the International Battery Production Conference, where also digitalization is a very important topic. And you can also hand in abstracts until the 3rd of June, so end of this month. And hopefully we will see us in November also in Braunschweig. And now I will close my presentation and come back to you.
Yeah, Arno, and we start sharing the menti.com platforms so that you can launch the questions.
Yes,
so
that's what I mean.
Yeah, I hope you can see my slide.
Yeah, perfect.
So I will move to the next slide in which you would be inserting the code.
Is it the same like before? No, it's a new one.
No, it's a new one.
So everybody has to put in the code or has to make a picture of QR code. Yes.
Okay, so shall I move to the next slides? Then.
Yes.
Okay.
So now we have, as I said, 5 questions, and Eli now is guiding us through these 5 questions. And the first one is, which are the pain points or bottlenecks in digitalizing digitalization the battery manufacturing process? So what is hindering that we are not always or already digitalized everything in battery manufacturing? And so you can give your suggestions in the Mentimeter. And Eli, do we see how many? So that's the number 17, yeah?
Yes, apparently 17 people answered the question.
And do we know what is the overall number? It's 38.
It's around, yes, 38.
Yeah. So please take your time. So in the moment, sensorization, so sensor technology seems to be a real bottleneck. So we need better sensors in the battery manufacturing, and that the equipment is not really adaptive. That means we can't change so much during the operation. That means also it's hard to control the process or to at least optimize the process during operation. And at the 3rd position, let's say together with the non-adaptive equipment, we have the lack of knowledge. So Eli, how much time do we have? Because
you have only 1 more minute, otherwise we can jump to the next question, if whatever you prefer.
Yeah.
Then shall we move to the next question?
I think we should move because there's no action anymore. No.
This is the second one.
So the second one is, which are the main expectations regarding digitalization and battery manufacturing? So what can we achieve by using digital tools? Yeah? So the most important points are the quality control and the control over the production stages. So that means that we keep the quality in the right, on the right level or in the right window, and also that we control the machines. I think that are really the most important ones, also to my experience. Speeding up the process might be not such, it's also maybe another goal, or can be an advantage, but it's not such a fast, but reducing manufacturing time, I think that's also, maybe speed up the process is also the development process, maybe not only maybe the manufacturing process, because it's manufacturing time. Also, we have 18 again, maybe the rest has problems to activate Mentimeter, it seems to be.
Yeah, don't be shy.
Yeah. It's really easy, so and nobody sees what you are typing in.
Maybe you can comment and know from your side, or what, or with your interaction with the clients, which are the main expectation that the clients have in this regards, maybe before we jump to the next question.
I mean, the clients usually want to have, first of all, a good planning tool, you know, to predict something like costs, and energy demand, for example, was very important last years, because this was a big issue, at least in Germany. So the energy demand on such production lines, and also to have an idea about investment costs for a certain production rate you want to have. And on the second line, now I think it's know where the lines are built. From my point of view, the control of the production stages gets more and more important. So that's what they want to have. And by the control, then also controlling the quality, and that you not only have the quality control at the end with the finished cell, that you control the intermediate products, and by that have a much higher production rate. So that means less scrap, so bad products. But I think now we can maybe move.
Yeah, okay. This is the third one.
So the question is, what are you doing to reach your goals using a digital approach in battery manufacturing? That means how you are coming to a digitalization in your company, or maybe in your research institute. So do you get an outsourcing or service provider? You recruit a specialist, or you have a partnership with a specialized company or maybe institute. You start an in-house training or have an in-house department on digitalization. So you see that in the moment, in-house training is the most important one. That's also what I think, that it's very important to teach the people in the company or in the institute on digital tools, and to show them what they can do, and to break, let's say, the fear, you know, by using that. I think that's very important, and also to have contact to specialists. That means specialized companies or institutions also research institutions who know which digital tools are available, maybe which have the models and simulation tools, and to work together with them, because it's a lot of work to start, by having nothing. I think, especially for modeling and simulation, you need a lot of knowledge and experience. So it's, I think, very good to have partners. And in-house department, if you are a big company, then it's really nice to use an in-house department. So I think that's something, depends on the size of the company, what is important or what way you go, maybe using a specialized company or using an in-house department. And especially if you have not the knowledge up to now, then it's for sure also good to recruit a specialist. That means who can add the knowledge on digitalization to your team. And that's also what I think, starting with in-house training is for sure, that's what is the most important point. Then if you don't have somebody who is responsible for digitalization, then you have to recruit somebody. And then the question is regarding special tools and deep knowledge. If you are a big company, then you can use your in-house department. If you are a smaller company, then I think you have to have partnerships with specialized companies or research institutions. Okay, I think.
Yeah, shall we move to the fourth question then?
Yes, yes.
Okay. This is the question.
So that's also more answers are possible. So which steps are most difficult to simulate to reliably predict cell structure and quality, as well as production costs and environmental impact? That means which process steps of the entire manufacturing line you think are most difficult to simulate. Yeah? Not most important, but most difficult to get reliable results. And maybe not taking every production step, so maybe up to 3, so that we get a good picture. So it seems to be that it's not such a big difference. Okay, I think we already have the 18 who are normally taking part in the Mentimeter questions. So that means formation and electrolyte filling seems to be the most difficult ones. Then following by the mixing and wet and dry mixing of the materials, and then coming to electrode coating and drying. And what is not so difficult is calendering and cell stack assembly. And that is what I think it's also, my opinion, I would say electrolyte filling is also not so difficult, but I think other than that, it would be that's what I was expecting. So formation is really a very difficult process, especially regarding then also how the cell behaves regarding aging later on. So not only the formation step in the manufacturing, but also regarding how the resulting chemistry, let's say like something like SEI, then influences the later operation of the cell. Okay, then we can also go to the question number 5.
Okay.
So it's a little bit similar. So now the question is, which production steps are most critical to implement intelligent control systems to reach maximum product quality and minimum product waste That means critical in the form of which are most important. So where we have the highest impact if we can have such a control system. Or on the other side, where we lose the most money if we don't have a good control. So here we have a much more clearer view on what is most important. So what is, I will wait before everybody has given his opinion. But that's what I also think electrode coating and drying is very important, because this is also from my experience, the process step where the highest amount of failures can occur. So that means we can produce a lot of electrode scrap if we are not controlling this process step really nicely. Then the next one is formation and aging. Also here, if we have not controlling the electrical parameters during formation and temperature during formation, then also we will have product quality changes, but maybe not producing, from my point of view, not producing so much scrap. So important is then to use this aging also as a quality control step. And then we have the electrode calendaring. For sure, if we not have a smooth control there, then we will have different densities of the electrodes, and by that also different capacities, or at least energy densities. I would say they are maybe not so. I would expect that the electrode slurry production is more sensitive and more critical, because if you have make a mistake there, and then usually that will give a bad electrode coating, and then you will also have not a good electrode calendaring. So that means you see the problems you have in the slurry production then later on in the next two process steps. But it's clear that electrode production steps are very critical regarding having a control. And then the last step of formation and aging. The other steps are, according also to your opinion, not such critical regarding controlling, but I think electrolyte filling, also the amount of electrolyte you dose into the cell is very critical. If it's not enough, then the cell will not work nicely. If it's too much, then you lose or you have a higher weight, and also that is not what you want to have.